Alright, this is worksheet 1 of our factor label packet. A little forewarning here. As we get going, some of you are going to start wondering if this is really chemistry. And the truth is, it's not. Factor label is a problem-solving technique that you are expected to learn in this packet so that you can apply it to the next 3 packets where we get back to chemistry. And as we do some examples, some of you are going to think, geez, these aren't very complicated. I could solve these without this technique. Might even be easier. And you're probably right. But what you need to keep in mind is that I'm not really concerned in this packet with your final answers so much as how you set the problems up. Because when we get to the last couple worksheets in this packet, and particularly when we get to the next 3 units where we're talking about chemistry that's not as intuitive and familiar as the examples in this packet, you're going to really need to rely on this technique. So this is your chance to practice it and get good at it with some easier problems. So really what you need to take away from this lecture is how to use a simple equation here. Every single problem in this packet is going to be set up by first writing what we want to find, or what we're trying to solve for, and setting it equal to what we know, or what number and units we have been given. Then we are going to set up a fraction that will be made out of a conversion factor. So what do I mean by a conversion factor, right? You might know, for example, that 1 liter equals 1,000 milliliters. Okay, and if you didn't, that's okay, because we'll provide these to you. So from that conversion factor, that equality, you can make a fraction. You can make a fraction where 1 liter is on the top and 1,000 milliliters is on the bottom, or you can make the reverse fraction where 1,000 milliliters is on top and 1 liter is on the bottom. You can make the fraction in either direction because either way what's on the top is equal to what's on the bottom. And we are going to use the fact that we can choose the direction, so to speak, of the fraction to our advantage, because we are going to choose the direction of the fraction to allow us to cancel out units that we do not want in our final answer. And this may seem a little vague right now, and that's okay because hopefully it will become more clear when I give you an example. But before we get into examples, I want to address the fact that some of you might be feeling nervous that you did not know that 1 liter equals 1,000 milliliters. That's okay. You don't need to memorize that. You will be provided this. So I need you to look at the page just before this worksheet, which I am going to pull up on the screen. Okay, so you are now looking on the screen at the page just before worksheet 1, and there is a common conversion table just below the polyatomic ions on your periodic table that you have probably looked at 100 times and never thought about. But now you're going to. So it's good to know the organization of this table. The first column deals with types of meters. So kilometers, millimeters, centimeters. And it's got all these equalities, right? 1 meter equals 1,000 millimeters. The second column is all types of liters. So 1 liter equals 1,000 milliliters, for example. Third column is all types of grams. So 1 gram equals 1,000 milligrams. The fourth column's a little different, right? These are English units. So meters, liters, and grams are all types of metric units. In other words, units used all around the world. English units, however, are just used pretty much in the US. So you might kind of think these are more familiar to you. Inches, miles, feet, pounds, all that good stuff. Every once in a while, we're going to need in these problems to convert between English and metric units, so that's what this last column is for. And then at the very bottom of the last column, some time conversions, which you might already be familiar with, like 1 minute equals 60 seconds, right? Okay, so once you are familiar with that, we can go back to our slide. Here we are. So let's do a sample problem. The first problem is asking us how many liters are in 156.2 milliliters. So what we want to know is how many liters we have, and what we have been given is that we have 156.2 milliliters. All right, so we are going to use the conversion actually that I put up here, which is that 1 liter equals 1,000 milliliters. And we are going to set up what I call a picket fence, okay? Because this is going to help us kind of organize what's on the top of our fractions and what's on the bottom. So here we could use this fraction, or we could use this fraction. They're both true. We're going to choose the first version of the fraction, though, because if you notice, right now our information is in milliliters, and we want to get rid of the milliliters and convert them into liters, which we're asked to solve for. So if I use the first fraction, I have 1,000 milliliters on the bottom of my fraction and 1 liter on the top. Important rule: whenever you have the same unit on the top of your fraction as you have on the bottom, you can cancel them out. They undo each other. So now the only unit that we have left is liters, which is good because that's what we were asked to solve for. At that point, we are ready to calculate and come up with a final answer. How do you calculate? Well, important rule. In our picket fence, anything that is along the top gets multiplied. So we'd have 156.2 times 1, which of course just gives us 156.2. And then anything that's on the bottom of the fraction gets divided. So we'd have 156.2 divided by 1,000, which gives us 0.1562. And I don't want to leave my numbers naked. That embarrasses them. So I'm going to put my unit of liters. And I'm going to box my final answer. All right. So we can look at another example. Number 2 here. This time I am asked to solve for centimeters, and I am given 9.85 meters. So, same format as before. Set up my picket fence. And this time, if I go back and look at my conversion table, I can see that 1 meter equals 100 centimeters. So when I set up my fraction, this time I'm going to put the 1 meter on the bottom and the 100 centimeters on top. Because this time what I'm trying to get rid of is meters, and what I want to end up in is centimeters. So if I have meters on the top and on the bottom, they cancel out. Now my only unit left is centimeters, which is what I want. So I'm ready to calculate. I multiply across the top. I could divide by 1, although that wouldn't change my final answer. which means that I get 9.85 centimeters. So, in summary, if I want to cancel out a unit that is on top, like when I tried to cancel out meters or milliliters, right, I need to multiply by a fraction with that unit on the bottom. Okay, so these were one-step factor label problems, right? That's what worksheet 2 is going to be all about. But when we get to worksheet 3, we're going to have two-step factor label problems. This happens when we are trying to convert between two units, and there's not just one conversion in our conversion table that gets us directly there. So, for example, in problem 3, we are asked to solve for centimeters, and we are given kilometers. So, I still set this up the same way. That's not going to change. I still set up my picket fence. But when I go to look for a conversion from kilometers to centimeters, there's not one. So, what I notice is that I can get from 1 kilometer to 1,000 meters, and then from 1 meter to 100 centimeters. So this means I'm going to have to set up two fractions, one after the other. My first goal is to get rid of kilometers. I don't want that in my answer. So I use my first conversion. I put kilometers on the bottom, meters on the top, and that allows me to cancel out kilometers. Now, if I solved right now, my final answer would be in meters, which is not what I want. So I have to put another link in my picket fence. Now my goal is to get rid of meters. So using my second conversion factor, I'm going to put meters in the bottom, 100 centimeters on top, and that allows me to get rid of those meters that I didn't want. I've now used both of my conversion factors. My only unit left is centimeters, which means that I am ready to solve. So, if I solve this, I am going to multiply and multiply. I could divide by the ones that are on the bottom, but in this case that wouldn't change my final answer, and I get 4,600 centimeters as my final answer. Alright, last problem. You better have a calculator, because I'm not going to do the final calculation for you. We'll set it up together. I want to find how many seconds are in 3 days. So, I want to know the number of seconds. I've been given 3 days. I make my picket fence. Alright, I might not know how many seconds are in a day, but I do know that in 1 day there are 24 hours. So that allows me to cancel out days. And I also know that in 1 hour there are 60 seconds. So I cancel out my hours. Now my only unit left is seconds, which means I'm ready to solve. So I multiply 3 times 24 times 60. I could divide by 1, although it won't change my final answer. And you're going to need to get your calculator out and do that multiplication and make sure that you don't leave that number naked. Alright? So, examples 1 and 2 that I just did are like worksheet 2. Examples 3 and 4 that I just did are like worksheet 3. That's what you will be doing when you come to class next.